Is it everyone already done on the BGP? Are you able to solve that? All right. So over here, let me just show you that how it can be done on the IPv6 BGP question. So first, we need to form the eBGP first. When we form the eBGP, we have to use a direct connected. Since that they did not mention have to use any loopback address to configure it. So in this case, I'm just using the direct direct IPv6 to perform the configuration. All right. So I first go into the ASPR1 on the ASPR1. So you need to first need to know which interface they're connected to each other. Okay, let me just scroll up a bit. That is under the gate 002. Okay, under a gate 002, that is where we defining the eBGP. Okay, IPv6 eBGP4 plus. So I'll go back to this and check. Display IPv6 interface brief. That's 701. I'm 5701 opposite 5702 or 00. Let me check. Display IPv6 interface brief. Okay, this is the address. So always you can just copy. It'll be easier for you to perform the peering. All right. So under ASPR1, for you to form the peering if we can just doing like this, I would say that it's a BGP 100 peers followed by the addresses, AS numbers 200. Okay, that is how we are forming. And then IPv6 family unicast enables. So that is be the step they required to perform, and they need to advertise the loopback into the IPv6 tables. So I need to put the network. But before that, I need to know what is my loopback address. Display IPv6 interface brief. This is my loopback. I'm going to be advertised out. Network followed by my address is 128. Okay, this is how you're advertising. Okay, advertising your IPv6 into the BGP. Displayed BGP IPv6 routing tables. So that has been advertising out. Okay, has been advertising your locals. This is your locals. Okay, that is the configuration I did on the router AR router 1, ASPR 1. Let me just copy to this. This is on the number 5.2. Okay, that is on the configuration on the ASPR number 1. I also need to define under the ASPR number 2. Okay, ASPR number 2. Sorry, ASPR number 3. Sorry. So because it's 1 and 3 to form the peering. So for ASPR 1, this is my peer address. Let me just copy this. So in this case, I can easily show on the ASPR 3 to form the peer with you. So let me just clear this. BGP 200. Peers, AS numbers 100, IPv6 family, unicast, peers, and neighbors. So this is what I'm going to do on the ASPR 3. Okay, so let's just wait for a while for let the peer to come out as active. Okay, so let's check display BGP IPv6 peers. So you can see that right now I have a peer as right now established. So that is the peers 5701. Okay, router number 1. I'm 00 as a ASPR number 3. Okay, so after I done on this, for this I should receive displayed BGP IPv6 routing tables. I should know how to go to 505. Next hop is 5701. Again, that is where I receiving this information. And now they want to make sure that ASPR1 able to ping to the entire AS200 loopback addresses. I want to access to all the loopback inside the AS200. I need to do the mutual redistribution, as in I redistribute from here. First, for the OSPF v3, it be straightforward. It just import route BGP. Did I mention? Okay. Just import out BGP. Just now I did not copy this, right? Okay. Import route BGP under the OSPF. So after I've done this, I can just double check with the routers, like go to the R3, displayed IPv6 routing tables. So make sure that you can go how to go to the 505. Okay, it's the OSPF v3 ASE. You learn as the ASE route. So you have a lot, but that is the one they're referring to. That is where you learn from learned from the OSPF ASA. You import the BGP route into the OSPF v3. Okay, this is what we're getting. So that is correct. But right now, how I'm going to import my OSPF loopback address back to ASPR1? Only the loopback address. Okay, only the loopback. So how I should define from here is on the ASPR3. Okay, so in this case, we're going to build a prefix list just to match whichever as a loopback address, because all the address is already in my tables displayed OSPF v3 routing tables. Okay, 128, 128, 128, 128, 128. So that is the addresses I should advertise. 707 is myself, 909, 2222, 1111, 10.10, 1010. So that is all I need to be advertising to the ASPR1. So how are you going to match all these addresses? By using the prefix list. So this is how I perform IPv6 prefix. All right. Loop back interface. Loop in, loop back interface. Then followed by permit. Permit : 0. Anything. But what I want to make sure is greater, equal, 128, less, equal, 128. So this is what I make sure. This is what I want to make sure. And route policy, that is on the OSPF. If match, IPv6 address, prefix list, looped in. Okay, then I go back to the BGP 200, IPv6 family, unicast. Import route OSPF v3 and followed by route policy OSPF to BGP. Process 1, route policy OSPF to BGP. Okay, that is what I'm going to be performed here. So let me just copy this into the notepad first. Okay, that is a requirement I need to perform. And after you done this, let's check display BGP IPv6 routing tables. So you will see that you have a 707. Oh, there's a lot more. 709. Let me just go to ASPR1 and have a look. That's what I received. 505, 1010, 1111, 2222, 909, 707, and 808. So that is what they are receiving. Okay, on the ASPR1. So look back, it received already. So I can try to check. This is my source. I do a ping IPv6 minus A. From this, go to 77, let's say. So you get reply. So from loopback to loopback, you'll be able to communicate between each other. Is that all right? That is what the configuration that need to be done for this mock lab on the IPv6 BGP. So you need to know how we're going to be match all the loopback 0 address. Okay, loopback 0 and can communicate between the ASs. Is it okay so far? So any questions? Okay, yeah. All right. So that is on the mock lab. Okay, the mock lab that we are going across. So let me just save everything and give you a copy of this. For the loopback interface, it's not always 128. The loopback address, you can use any subnet mask, any prefix that you want to. Okay, just like v4 loopback is not always /32, but because of they have predefined as a /128. So in this case, we can using the prefix list to match the /128. It's not always. It can be any prefix that you want to. But because of we know that that is just a host address, so that's why we give us the first ideas is always 128, but it's not necessarily be 128. Okay, just like your IPv4, always we make our loopback as a /32. Okay, as a host. All right. So is everything okay? Shall we take a short break? Because I think that today we have to take a break at 11:30. Okay, 11:30 to 1:30 because today is Fridays. Okay, but At the moment, do you want to get a short break, like for toilet break? Maybe we just get about 5 minute break at the moment. Okay, 5 minutes, then we come back. Okay. So we just come back right now. It's 37. Let's say we come back to, you come back at 45 right now. Okay. So I'm going to be continue after this. Thank you. All right, so for the mock lab that we already completed, let's come back to some of the discussion that need to be going through with all of you, like what the preparation that we required for this exam, for the lab exam. So as I mentioned on the day number 1, so into the first you go for the written exam. Okay, written exam you'll be 60 question. Okay, so the passing rate is out of 600 out of 1,000. So it means that it'll be 60% for the exam. Okay, the passing rate will be 60%. After you pass that, then you go for the lab. Okay, the lab exam. So the lab exam at the moment that what you need to be concentrate into, I'm going to write it down. I'm going to write it down what you need to be concerned. Okay. So for the lab exam, normally they're just divided like this. Let me just change my colors. So they're always divided to layer 2, IPv4, IGP, MPLS VPN, features, multicast, and IPv6. So that is how they're going to divide the two. Normally, that will be the 6 topic they're going to test into your lab environment, okay, lab exam. So the mark between this one is about 14 to 16. Okay, this one is around 16 to 20. MPLS VPN is about 34 to 36 or 38. So the features, multicast is a bit less. And IPv6 is as well. Something like this. So that is what they would test you into your lab exam. Sometimes you have a features more, you have IPv6 more, and without multicast. Sometimes you have a multicast, then you have less features and less IPv6. But for this is the main. Okay, these 3 are still the main. And especially for the MPLS VPN is always the most critical. Okay. So inside the layer 2, what we need to get ready on layer 2. In layer 2, we need to know how to perform ether trunk. So hold on, let me just stop the lab. Otherwise, it'll be very lagging. Okay, so either trunk is the first thing that we need to note. Then the next we need to know like the link type. So what the link type that we have, like access type, trunk type, or hybrid. Okay, this is on the link type. And under layer 2, we also need to know about the MSTP. Okay, as well as we also need to know the WAN protocols, and the VRRP. So all this, we need to grab some ideas that is a basic understanding we need to know on this layer 2. I think most of them I already went through, like either trunk, link type, MSTP, WAN, and VRP. All this protocol already completed, right? So you need to know what is inside there. So like this one, either trunk that what we have two types. We have a static hold on, let me just try to restart one more time. You see what happened. Okay, there was static and also the manual. So the manual way of either trunk and also there was static LSCP. This one I can just put it as the LSCP instead of confusing you. Oh, I already saved. That is a LACP. So link type, just now I mentioned already that we have a trunk, access, and hybrid. But what you focus over here is you focus on the trunk and access. Just like what we perform early on the mock lab, that's how we need to define the access interface and the trunk interface. But for this, the environment they provide will be something like this. They will ask that they have a switch 1, switch 2, switch 3, and switch 4. Okay. So the topology is something like this. So they're going to give you multiple VLAN. They need to say that, oh, this is on the instant 1. That is on the instant 2. So that is the root of instant 1, and this is the root for the instant 2. Something like this. So they're going to ask you to perform all this method rather than what we did just now on the mock lab. It will be pretty straightforward. It's only 3 switches. But this one, they give you more ideas. They give you about 4 switches, okay, to define under the MSTP. Under MSTP also, you need to know how to use the HPOT. Okay, when we do it yesterday as well, and also the protection. How you define the protection. Okay, this is you need to know how to perform this. Okay. All right. So then the next one is on the VRRP. Oh, sorry, for the WAN. For the WAN over here, you need to know about the PPPoE or a PPP or HDLC. So these are the 3 different modes they ask you to perform. They might select one of them, either PPPoE or PPP or HDLC. Okay. Then VRP just define the VRID with the different priorities. This one also we tested out before into the mock lab as well. So that is purely into the layer 2. This layer 2, you need to know how is all this being performed. Okay. So for layer 2, I think that everyone, it should be fine, right? Any protocol that you are not familiar, you can just let me know. All right. So that is on the layer 2. So far, okay for the layer 2. Before I go for the next one, is that all right? All right. So the next one is on the IPv4 IGP. Okay. On the IPv4 IGP here, so what we need to be concentrate here is be very similar to the mock as well. So we need to concentrate on the OSPF, ISIS. So always these two protocol, they're going to ask you to configure. Like what we have is AS100, AS200. AS100 running OSPF, AS200 running the OSPF. OSPF and ISIS run on between, and they need to know how to perform the route control. So this time it will not like what we did on the mock. So they will do something like this. Okay, they will do something like this. So they're going to have AS100, AS200. So still remember that they have a ASPR, ASPR. So they might ask you that to these two nodes, they need to perform the redistribution from here and redistribution from here. So this is ASPR1, ASPR2. On a single routers, they need to do the redistribution. So in this case, you need to know how to perform the route control. In the route control, it will include the make sure that prevent the suboptimal way and prevent the loop. So that is the two things always they will ask inside the route control. So it means that you need to set all. When I import to you, I add the tag. When I import back to you, I deny the tag first and before I add the tag and so on. So that is where we go into on the route control inside the IPv4 IGP protocols. Okay, between OSPF and between the ISIS. So between the protocol, we need to know what we should do over here. Is it all right? Any questions so far? Up to the IGP. So for this IGP, it's not too difficult because it's only 16 to 20 marks. But that is all the easy mark. Okay, easy mark. All right. So in this case, we need to know how this is being done. OSPF basic, you need to know. You grab the ideas of the basic of the OSPF. So how you define, you might ask you to define the stub area, let's say that you know how to do. Okay. And this is on the level 2. You need to know what are the cost style you are using. The cost style for the ISIS. Is okay? All right. So for the IPv4 IGP, it's just configured based on the step by step. So for layer 2, this layer 2, you cannot lose any mark on this layer 2. The layer 2 is pretty straightforward. Let's say do not know how to configure it, is always refer back to the headers, the documentation. But that layer 2, it should not be an issue. But for IGP, this one you need to be aware because when you type a wrong IP address, you get a different result already. So you need to be careful when you configure the IPv4. Okay, when you configure IPv4, need to be aware on you do the wrong configuration here. Okay, so and you need to know the behavior between OSPF and also the ISIS. What's the difference between these two? Okay. So then the next one is on the MPLS VPN. So MPLS VPN over here is what we need to know. Straightforward, we need to know first how we configured a BGP. In the BGP itself, okay, we need to know the BGP. We need to know about MPLS. We need to know about inter AS options. Yeah, inter AS BGP options. So for BGP, we need to know the differentiation between the I BGP, E BGP to MP. Okay, so what is the difference between the IBGP, MP, IBGP, eBGP, MP, eBGP, the basic MPLS, like the LSR, LDP. So all this is on the basic as well as the BGP, LSP. Yeah, that is what we need to grab idea inside the basic MPLS over here. And the last one is on the inter AS option. Inter AS option, we're using quite a lot of time to just just to discuss on this MPLS VPN inter AS. So what have been done over here is we need to know the ideas about between the inter AS, what is related, what requirements, okay, requirement on the inter AS. So on the inter AS, we have option A, B, C, C1, and C2. So for this exam, they will always ask about C1, C2. Know the rest, you just focus on the C1 and C2. Is that okay? So you need to focus in between these two. Okay, C1, C2, that is on the MPLS VPN. But this over here, the mark over here is pretty high, from 34 mark to 38 marks. So that's quite a lot. And this one, I can tell that at least you need to take about 2 hours plus just to focusing into this MPLS VPN. Okay, about 2 hour plus, 2.5 hour maximum, go up to 3 hours to just perform this MPLS VPN. Okay, so that it need to be aware. So that one, this one need to be pretty critical, because this one, let's say you miss any information from here, you might not able to continue. Okay, because when you're not able to do this, it means that you fail already. Because passing rate will be 80%. Okay, but this one will be about 34 to 38 marks. Okay, so it's quite high mark from this portion. So make sure that you need to know the MPLS VPN very well. Always remember that I mentioned when we're going to do these questions, what you should do. Write it down, the procedures, the progress one by one. After that, you should know how to solve it one by one. After you've done it, check whichever that it has been done. Is all right? That is on the MPLS VPN. So far, any questions before I move on? So from this, you need to know the process, define the instance, binding the instance, configure the BGP peering, configure MP BGP peerings. So C1 and C2, you need to know the difference. C1 using 3 labels, C2 using 2 labels, and what the extra things we need to be concentrate into. All right. So I think that from here, I will just add on another page. Okay. Okay. So 4, 5, 6, are you going to use the next page to show it to you? So the features. For the features, what we need to be concentrate into the features. The features that we have a HA, the high availabilities. The high availabilities over here is you need to know like what we're using as a BFD, bidirectional forwarding detection. Okay, so BFD, you can be this one can be linked back to your OSPF, can be linked back to your ISIS, or it can be linked back to your VRRP. Okay, so that's why on the HA, there another HA you need to know is on the VRRP HA. How you provide the high availabilities inside the BFD, using the BFD to provide the VRRP HA. Okay, that is what we need to concentrate into. Is okay? VRRP. So these are the two protocols inside like the high availabilities. And other than this, the features we have like the netting. We need to know how to define the netting. Net on the routers, you need to do one-to-one net or many-to-one netting. So there is a multiple way for us to perform the netting. So it depends on one you want to do one-to-one or multi-to-multi, multi-to-one netting. Is okay? And the next one will be quality of services. Okay, quality of services. The QoS. The QoS over here is they're going to ask about three type of questions. First is on the security filtering. Okay, this one like you're going to filter based on port. Okay, filter based on port, like based on the protocols. Okay, filter a TCP port from this range to the other range. And for this, you also need to know the time range. Okay, the time range, the scheduling. So when I'm going to apply with this policy, okay, the time range. This is also important. Okay. That's the first thing they will ask. Then they will ask for the CBQ. Okay. Class-based queuing. So from here, they're going to ask you that to perform the traffic classifiers, behaviors, and policy. Okay. You need to classify the traffic and what behavior you provided and combine these two to come to form as a policy. Okay, that is where they come from on the CBQ, okay, class-based queuing. And the last one, they will have a policing, how to police the traffic, how you're going to perform the line rate or car committed access rate. So that is always they will ask. So you might get the QoS or you might not get the QoS. But it depends on you get three questions or you get one question in the QoS. Sometimes you get three of the question or sometimes you just get one of them. Okay. So at the moment into the HCIE for the version 3 lab. Okay. For the version 3, version 3.0, they have only two sets. Okay. They have only lab 1 and lab 2 at the moment. Okay, so it means that when you take the exam, either you get the lab 1 or you get the lab 2. Or you let's say you fail the lab 1, you retake, you might still get back the lab 1 as well. Okay, so it just depends on what the probabilities that you're going to get this information. You might get the same information, okay, again and again. So they're lab 1 and lab 2. So these features, multicast and V6, it will be just random. But the one that does not mention, the first 3 is always fixed. Layer 2 is fixed, IGP is fixed, VPN is fixed. Okay, but the features, the multicast and V6, it will just depend. They will just, sometimes you have 1, sometimes you have 2. Okay, on that within the question. Okay, it depends on how they're going to be classified into it. So for these features, is it okay? So later we also will go through talk about the QS. I will going to show you about how we define the QS questions. Because QS, we did not go into any QS topic yet. So I'm going to focus QS in the later part. Netting, maybe I can just show you a little bit how we perform on the net. All right, how it's defined on the net. It's okay? So any question related to this, you can ask now. Just share to the WhatsApp group. You can just unmute yourself and just voice out. Okay. So after the features, the next things you need to be concentrate will be on the multicast. Okay. For multicast, you need to know about IPv4, PIM, SM, and also IPv6, PIM SM. So when using IPv6 PIM SM, this is using the IG, MP version 2. This is using the MLD version 2. So you need to know which version you should be using into this. So normally they will ask you about the SM or only SM. Let's say they want to ask a bit difficult, they will ask about SSM. So they will never go back to the DM. Okay, they will never go ask to about what is a dense mode. Always when you ask a sparse mode, they want to test about how you define the CBSR and also the CRP. Okay, so this question is sometimes you have it, sometimes you not have it. You might have multicast question or totally do not have multicast question. Okay, let's say you have multicast question, then you have less QoS question. So that is how they're going to take and give. It's okay for the multicast. That is on the what we need to be concentrate into the multicast, like PIM SM on the V4 and V6. You need to know the differences. So actually, the differences is not a lot differences. There's not much of difference between these two. So what you need to know when you configure this, always remember to perform the multicast IPv6 routing enables. Where compared to V4, it's just multicast routing enables. So without the IPv6. Just same to the, when you enable the PIM, you need to do a PIM IPv6 SM. You need to add a V6 in between. That's all. So actually, the configuration wise, there's not a big differences. Okay. For multicast, that is what need to be concentrated. Is it okay? So far, okay. Any questions? All right. So, and also, let's say they ask about IPv6, they always, as a base, is inside the ISIS. Okay, ISIS IPv6. Let's say they'll ask for the V6 multicast, always is inside the ISIS IPv6. Because for the OSPF v3 in the simulators, they do not support. Okay, they do not support that. So they have to do it on the ISIS. So in your exam, also, they're just using the simulation. Okay, simulation. And the last one over here is on the IPv6, IGP, and EGP. So that is what we did as well. How you need to know how to configure IPv6, ISIS, OSPF, v3, and BGP 4 plus. So this is what you need to know how to perform. So far, okay. So that is on the different category. The category of the layer 2, IPv4 IGP, MPLS VPN, the features, and also the IPv6. So always in your exam, this is what you look into this, as well as a multicast included as well. All right, let me check what's question that we asked. So between IPv4 v6 different topology or same? Yeah, using same topology. The topology will be just similar that what we used into the mock lab. Okay, the topology is something like this. Okay, it's something like this. So they will go into like that have a host. Okay, the host connecting switches. Okay, then connecting to your CE, then connect to the PE. Okay, then connect to your RR. This is the P. So they only have one RR. Then go to the ASPR. If there's something like this, then opposite another areas. So this one is consider one ASS like this. No, not one AS like this, sorry. Because this is on the customer side. So one AS is from here. AS100. So they're going to have another one similar things on the other side. So the topology for the V4, V6 will be the same. And also when you configure under ISIS IPv6, you need to enable the MT, multi topologies, to support the topology for V6 and V4 are separate. It's called as a multi topology into the ISIS IPv6. So this one you need to be aware as well. Is that okay? So any other questions other than that? So no any other questions so far? So that is on the lab exam itself. On the lab exam itself, this is what you need to be get ready. So it'll be very important. So make sure that you know every single protocol very well, because the exam is not just like what we do into the mock lab, because they also involve of the route control. And when route control you do it wrongly, you a bit difficult for you to continue with the MPLS VPN. So the route control is also very important to make sure that you don't do any mistake from there. There's a mistake on there, it's very difficult for you to continue with the MPLS VPN already. Is it okay? So is everyone ready for the lab exam already? Anyone in the group already taken the written exam? Or now is only waiting for the lab? Or you have not passed your written yet? So is everybody took the written exam? Not yet written. Okay. indicate you need to take some time for you to get ready on this written. So later after the lunch break, I will come back to all of you to give you some ideas how you're going to get ready on the written exam. Okay. All right. So most of you have not taken the not taken the written yet. All right. Understood. Okay. So in this case, I think that it's just let us go for our lunch and also the prayer and come back around 1:30. We come back and continue this. Okay. All right. Let's go for lunch and also the prayer. Thank you. All right, welcome back. Is everybody back? All right, so is everybody back already? So over here, I'm going to go through, since that we have some more time, I'm going through another two topic. The first topic I will cover is on the HA, the high availabilities, and also the network management, as well as the QoS topic. So these are the two topics I will add it in. All right. Since that all of you have no question related onto the lab, so right now I'll give you some more of the theory on the HA as well as on the QoS. So this topic we go into is on the high availabilities. Under high availabilities over here, they're going to grab some idea to understand what is meant by the BFD, like how you're going to provide the non-stop forwarding, non-stop routing. So that is some of the things that we need to go into. Okay, on the HCIE, INS, HA, and network management. So for this forward over here, always we know that the network must be service continuity requirement in addition for the data connectivity requirement. So we try to make sure that they can have a providing on the high availabilities into our network to detect it, let's say have fault occur, how quickly they located and rectifying the fault. Okay, so how are we going to be speed up the entire convergence, as well as what type of network management protocol that we can support using the Huawei devices. Okay, from this topic, we go through on the deploy HA technology based on the application scenario and manage network and quickly locate the network fault. So first on the HA technology. HA technology normally over here we're going to consider as a NSR, NSF, as well as they will have a BFD. Then also there can be some of sort of the hardware redundancy. Okay, redundancy, non-stop routing, non-stop forwarding, and also bi-directional forwarding detection. So that is where we go into on the HA technology, and also based on the application scenario that we're going to go through. And for the network management, that is more into how we're managing the environment, like using the SNMP, using the NetStream, and so on. That is on the protocol we're going to be used into manage and quickly locate the network fault into our environment. So first on the HA, we need to understand what it means by HA first. On the HA overview. Under the HA overview, HA means that you will try to make that device have a higher availabilities. So you try not that, you can only run a half an hour, have to rest for half an hour, and run another half an hour and rest another half an hour. So that is not considered as high availabilities. For high availabilities, is mentioned that for throughout a years, what are the availabilities percentage that you can provide to? So how long is availability for you? Do you require restart throughout the years? Do you require maintenance throughout the years? So this is all in take to as a consideration. What are the total availabilities that it can be available into the periods of times? So it's entire years. 1 years, what are the availabilities? Maybe it's about 365 days. I will only want to maintain about 20 minutes a year. So that is what they can be provided. Even I need to go for maintenance, I still have another redundant devices or redundant part, or they have redundant protocol for us to take over. So they do not make these services interrupted. Okay, that is what we call as the high availabilities. Under the high availabilities characteristic, they need to make sure that they have a low fault occurrence and quick recovery after a fault occurs. So make sure that lower down the fault occurrence, so they will not keep on occurrence. Okay, maybe a year is only one or twice. Okay, every time is not more than 5 minutes. So how fast can be recovered? Let's say you found that that is a 40. How fast that you can recover back? That is based on what is your HA that the device can promise. So most of the Huawei device, they will say that their HA is up to 99.999%. Especially like the NE device, NE40, like S12700, they're going to up to 99.999%, 59 in total. So how we going to get this percentage? This is how we get the system availabilities. The MTBF divided by the MTBF plus the MTTR. Mean time before failures. Mean time to repair. Okay. So for MTBF is the mean time between the failure of the component or device. So what's the time that you're going to be between the failures? Between failures and come back. Okay. So that is where is between the failures. MTTR is a average time required for a component or device to recover from a fault. So mean time to repair. How long you're going to be repair? They're going to come up with this information with the 99.999%. Yeah, that is how they are calculated with the high availabilities. Okay, that's on the HA overview. So definitely, the lower the MTBF, the lower the MTTR, you get a better system availabilities. Okay, this is always how they be calculated. Okay, under the high availabilities of the card or the modules or the chassis or the device. Okay, they have a different type of HA that can be applied into the devices. And for us to provide the higher HA, we need to work together with other protocols. Like the first one mentioned over here is called as a BFD, bidirectional forwarding detection. Okay, as a BFD. BFD is a tool for us to quickly detect and identify connectivity of the link and also IP forwarding on the network. So this is how they can be detected. How fast they can detect in the BFD? Have you used the BFD tools before in your environment? So BFD, the fastest they can go up to is around 30 milliseconds. Okay, 30 milliseconds. It means that it's 0.03 seconds. They can detect the fault. So they can detect the fault, identify the fault only. They are not doing any recovery. This is just a detection. So that's why it's called a BFD. It's just meant for the detection only. Yeah, just meant for detection. So after detected, they will just alert to NMS. So they alert back into your SNMP to say that, oh, right now this link is go down. But that is a standalone. Standalone, they need to be just alert back to NMS. You also can using like this. OSPF, BFD. ISIS, BFD. VRP, BFD. By doing so, when they combine together with the OSPF, ISIS, or VRP, then they're not only detection by BFD, but the fault rectifying by the routing protocols. Okay, when I detect using 30 milliseconds, after I figure out or link go down, I inform OSPF, hey, OSPF, this link down, please converge again. So they do the recalculation by the OSPF using the PRC, partial route calculation. Same to ISIS. Anything BFD detect, they will just alert to the ISIS. Okay, so this is combine the protocol together. Otherwise, the BFD can run standalone. Okay, they're just detecting and alert to your NMS, or they can be used together with the routing protocols. So that is a BFD. Okay, can be using either one. All right, and BFD is just using a UDP port 3784. This is a port number they're going to be used. Okay, source will be just random source, but this is a destination port that for them to maintain the BFD session. For BFD session must be defined as a both direction. So let's say I want to form a BFD session here. You need to configure on the router 1 and also router 2. Okay, to form the BFD. Remember that yesterday when you're doing on the what's the beginning when we do it on the VRP. Okay, when you do VRP, we define the BFD as well. Remembers? Under BFD, we do it on the interface. We bind the peer IP address. Okay, but I need to do it on the both direction. On the CE, PE, I need to perform. This must be both directional, must be bi-directional. Okay, always must be bi-directional. So for BFD session setup, so they have multiple ways for you to set up the BFD session. You can be using a static way, or you can using the OSPF dynamic way, ISIS dynamic way. Okay. So in this case, for the let's say you set up on the OSPF. OSPF use the hello mechanism to discover the neighbors. And OSPF will notify the BFD of the neighbor information, including the source and destination address. And the BFD, you start to form the BFD sections based on received neighbor information. So it means that first OSPF neighbor is being formed. Okay. And OSPF information, you give it to the BFD. And BFD, based on this information, I build the BFD neighbors. So this is combined between routing protocol with the BFD. Okay. First, OSPF must have peer first. After your peer has been up, then I'm going to be exchange whichever I learned from my neighbor and put this information to the BFD. Okay. Always remember that when we define BFD, you have to tell that where is your destination that you are peering with the BFD section. Okay, that is where it need to be set into the BFD neighbors. Okay, so after the session is being built, then they would, okay, when the session go down, the fund BFD go down. So what they're going to do? So they're going to alert to the OSPF. Hey, OSPF, please recalculate the information. Okay, that is how it can be done to form the section setup on the BFD together with the routing protocols. So this is on the routing protocol. They also support using the independent. Like independent, as I mentioned, how they're doing independently. That's what I show you from the mock lab just now, yesterday. Okay, how we define the static BFD. So static BFD, what we're going to do here is you always do it like this. Yeah, BFD, then BFD followed by the name. So let's say I do it standalone. I put as a OSPF. Okay, bind peer IP of the router number 2 and interface. Let's say it's a gig 001. And after you're done on this, you still remember what's the next? You need to define what is your local discriminators. Okay, the discriminator locus is 1, then discriminators remote 2. So this is how you're going to do it as a statically. You do it statically way, that's how you need to be defined. Remember, that's what we showed yesterday. Remember? And under the BFD fault detection, how they detect the fault. So in this case, it can be first, you'll detect fail on the BFD enables. Okay. When detect link fail, BFD session go down. When BFD session go down, it's notified to OSPF. OSPF notified that, oh, my OSPF peer go down as well. So that is going to be layer by layers. From first, second, third, and fourth, then the other way around will be 1, 2, 3, 4. How they alert back into the OSPF peers to say that right now everything just went down. Is it okay? So far, any questions? The workflow. Okay, so let's say that no question. Then next is on the session management. Session management. So BFD session management, the BFD session state can be down, init, up, and administrative down. So there's only 1, 2, 3, 4. So administrative down, it means that you shut down yourself. You shut down the BFD sections. Normally, we only see these 3 states. This is state number 1, number 2, and number 3. From down state, init, and up to the up state. So BFD state machine set up a release and set up and release using the 3-way handshake mechanism. It will be very similar like the TCP connection. Okay, very similar to TCP connection. Just a bit of differences from here. They're going to using the UDP port 3784. That's the port they are using to managing the BFD sections. Is it okay? So that is on the BFD sessions. All right. They're going to, at restarting, they are on the downstate. After you configured the BFD on the device, on the interface, they start to send the control bucket back into the device. Then they start to initialize. Make sure that my locker is your remote, your locker is my remote. Then we can specifying this to be up status, okay, on the session tables. And the next one is on the BFD on the application. As I mentioned just now, BFD can run multiple applications like BFD for IP link. Associate between the BFD session status and on the interface status.
static route, OSPF, ISIS, BGP, MPLS, LSP, VRP, even PIM as well, it can be done on the detection. So that is on the benefit they are talking about. So what they can be performed by using all different type of the BFD application. Okay, that is all the application that we're talking about. So the more important over here is the discriminators. The discriminators you need to set correctly. My local as your remote. Your locals is mine your remote. Okay, remote and local must be matched. White versa. Is all right? This is on the BFD application scenario. So far, okay? So definitely they will ask you this BFD question, but it depends on how they're going to ask you this question. It could be inside your IGP, or it could be inside your layer 2. Okay, like VRP that's defined on the BFD. When detect the failures, that's what should we do. So for the next one is on the non-stop forwarding. Non-stop forwarding. So this said that when a neighbor routers fail, neighbor at the routing protocol layer detect their neighbor relationships are down and then become up again after a period of time. This is called flap of the neighbor relationship. The flap of the neighbor relationship causes the route flapping, which will lead to the backhaul route or the restarted routers cause the data service from the neighbor bypass and restarting devices. Let's say you have anything flapping. Let's say I do recalculate my peers, that will cause a lot of problem. Okay. So for this non-stop forwarding, it means that if a fault occurs in the system, forwarding plane services are not interrupted during an active standby switchover. This active standby switchover is meant for your MPU, your main process unit. When your main process unit doing the active standby switchover, you will not affected the forwarding plane. So the data are still continuous forwarding out from your locations. Okay, that is what it means by the active standby switchover without interrupting your forwarding plane, because it's just an MPU switchover. But this one definitely you require that you need to have two MPU. Okay, without two MPU, no, it's not possible. Okay, after the system restore configuration, a device re-establish the neighbor relationship and obtain routing information from the neighbors to rebuild the routing tables. Okay, when they restore, I need to get this information from the peers. Okay, since that I do the switch over already. So in this case, for me to maintain my neighbor relationship, I can just rebuild my routing tables, get from my peers. So it means that you need to run on the GR. A graceful restart. A graceful restart needs to be supported among your neighbor routers. Your neighbor, you're going to keep this information for me for a while before I drop the information. Yeah, when I switch over, after I switch from active to standby, when standby take over, I need to be easily catch up and rebuild the route information by collecting information from my neighbor's routers. That is called the GR. All right. So by using NSF, it must meet to these three requirements. First requirement will be RPU. You must require it. Okay. And the active standby card are synchronized. When the active run normally, it sync the configuration and the interface status back to the MPU. That is required. And the last one, the protocol requirement will be the GR must be supported for related network protocol, such as routing protocol running on the OSPF, ISIS, BGP, or even LTP protocols. They need to support on the GR. Okay, to say that we want to restart, I'm going to keep this information for you for a while. So I keep this information. I will not tear down the peers totally. So when I come back, I form the peer review again. Okay, to speed up the process. I do not need to really send every single bit by bit anymore. I just ask my peer, hey, hold on, I'm going to restart. You as long as you are my GR routers, you keep the information for me first. Hold on, don't tear down the peers. I will come back within the period of time. Let's say within the period of time you're not coming back again, so I'm going to tear down the peers after the timer expired. That is called the non-stop forwarding. Yeah, non-stop forwarding. Is all right? So the next one, compared to the what we mentioned just now on the NSF, the next one is called NSR, non-stop routing. Okay, non-stop routing, the protocol backup mechanism ensure that the control plane and the forwarding plane are not interrupted during an active standby switchover. Okay, controlled and the forwarding. By right, control it should go down immediate, because when you switch over, you'll be interrupted already. But by using NSR, they will show that they would not get any interrupted on the control as well as on the forwarding plane. During the switch over, route process is not interrupted because neighbor and topology information is not lost. No neighbors relationship it goes down, okay, when you define as an NSR. But in this case, for the NSR workflow, you have to batch backup, real-time backup, and the AMS, AMB, and SMB switch over. So it means that they need to perform a patch backup. After the NSR is enabled on the SMB, restart. The service process of the AMB receive a message indicated that, oh, the SMB goes online. After receive the message, the backup the data back into the SMB. Okay, so this you can be doing the badges backup when the first your standby device is coming up. Okay, so that is the way for the NSR switchover. When by right this is active, this is standby. Okay, they're going to be synced with each other. They back up the information to each other. When the switchover, the packet is still forwarding, calculating is still continuing without any interruption by using the non-stop routing. Okay, non-stop routing. The non-stop forwarding, just to say that I will maintain your forwarding even you switch over. But non-stop routing, it be considered two things. Make sure your routing is not being interrupted as well as your forwarding is not being interrupted. That is on the two-way prevention. Okay, two-way prevention for the non-stop routing. Is okay? So that's why in this case, when using NSR, the active standby then must running two different type of the protection. The grateful restart and also the NSR. Okay. So then the next one is on the network management protocol. Under network management protocol, we have SNMP as well as a NTP. Simple network management protocols and also network time protocols that be included inside the network management protocols. So what's the difference between these two? Are totally different things. SNMP is more to sending the information, the query information, response information back to your NMS. This is to monitors and manage devices. Okay. For NTP, is more to time synchronization. Okay, to synchronize the time by using the NTP. Okay, that's on different things. Is all right? The two different things on the SNMP and the network time protocols. So for SNMP, basic concept. So basic concept over here, SNMP is called Simple Network Management Protocols. They are using the port number of UDP 161 and UDP of 162. So they have two different messages they're going to be sent in between the agents and the NMS. So this is NMS. NMS in Huawei, this one requires a eSite. Okay, eSite. And this is your managed device. So it means that your routers, your switches, your firewall is called a managed device. Okay. SNMP use a central computers that run network management protocol to manage your devices by having three different versions. Version 1, version 2C, and also a version 3. So later we're going to go through more in depth what are the differences between V1, V2C, and the V3. And for the SNMP model, it's something like this. Inside the managed device, we have an agent and also we have a MIP. MIP is called Management Information Base. This is a managed object. It's a bridge between the NMS and the agent and also enable the NMS software to interconnect with the device by using this MIP information. They're maintained by this agent based on the MIP information that I have and send response back to the NMS. So it's just like that is called the MIP tree. It's a tree of information of the database. Okay. They give you a lot of different information database to say that right now, NMS query. When I query, you need to know which direction you go to. So that's where the agent work together with the MIP. So sometimes you will see that in your console, they come out with the OID from 2, 1, 11, 5, 1020 and some more and something. This is to tell you that this is the location from the MIP location. From 2 on top, the first one, then the 11 and 5 and 1020. They're going to have all the numbers to figure out what are the response I should respond back to the NMS. So that is on the MIP tree. So the MIP tree is very important. Without the MIP tree, you're not able to advertising the information back to them. Is it okay? Any questions on the SNMP basic concept? So the next one is on the SNMP version 1, version 2C. What's the difference between version 1 and version 2C? So you can see that from here, they will have a 161, 161, 161, 161. It's just purely using 161 over here. So what's the difference between 161 and 162? So always we call this as a 162. Sorry. Sending a threat message. So regarding that, which version that you are using, that's a port they should use. Okay. So NMS UDP 161, agent UDP 161. Okay. So get request, respond, get the next request, respond, set request, respond, and the trap. Trap is only by the agent to the server. Okay, only one direction. All right. But for the new operation compared to the version 1, we have version 2C. Version 2C, they will not send the get request one at a time. They send a bulk request and respond fully. Inform request and respond. So the inform request over here is send the alarm to the NMS. Okay, this one is considered as a trap. NMS, you get response that, hey, I acknowledge that I received your alarm. Okay, so for these two versions, version 1 and version 2C, actually they have a weak securities. Although they're using UDP is not strong enough, and also they do not have a very secure way of the information to send send the SNMP information. So everything is sent across 161 and 162 is all a plain text. It's a plain text only. So they do not include any information on top of it. It's just a plain text they're going to be sent between the agent and to NMS. So it's just a plain text, no encapsulation. Let's say you want to have a better securities, so you should go forward to the SNMP version 3. Using the SNMP version 3. SNMP version 3, you get requests without security parameters to obtain related parameters, return related parameters, and request for the security parameters. Return related for the parameters. So it means that this time I will ask for the authentication. Okay. So that is how they're going to be communicated using the version 3. Version 3, they will be very similar to version 2, just that version 3, they're going to provide a higher securities. Okay, higher securities. They need to base on the username and also a user group to perform the encryption and decryption. Okay, they need to decrypt the information by getting the information. They need to be set the same decryption mode. The address, the user group, the user information must match before they can continue. Okay, that is a requirement they need to know on the version 3. Is that okay? Any questions so far for the SNMP? Okay. And the last one over here, we go through this one as called as a NTP. Network Time Protocols is called NTP. So what NTP is performing? NTP is performing the time synchronization into your local environment. Okay, they communicate with the local environment. So far, right? So for the network time protocol architectures, they have a synchronization subnet. So that is a subnet. The entire, okay. So this one is including the consists of the primary time server, Stratum2 server, PC client, and the interconnected transmission path. That is entire subnet that you're talking about. And this is your primary time server, Stratum number 1, Stratum number 2, and so on. And the PC, it could be just a client. Okay. Primarily time server, it be direct synchronize the clock with the standard reference clock through the cables, radios. Okay, that is always your reference clocks. So always you also can get the radio clock, or you can get from the GPS. For the Stratum number 2 time server, this one will be synced with your primary, sync with the primary time server. So that's why they get as a Stratum number 2. You can have Stratum number 2, Stratum number 3, 4, 5, depend on which layers, how far away you are. Okay, maximum Stratum can up to the 16. Okay, up to 16 hop away. So that's called the Stratums, the hierarchy standard for the clock synchronization. It represents the precision of the clock. The smaller the number, definitely you have a higher precision. Yeah, the smaller the Stratums, you get the higher precision. So number 1 is the top. Number 15 is the lowest. And let's say, just now I mentioned that it's 1 to 16 for a stratum. 1, the best. 16 is not sync. It's not synchronized. So it means that the lowest in the stratum is 15 stratum. 15. 15, it means that it's the least one, the least synchronizations. So far, right? For the stratum. Okay. And for the NTP, working principle. So NTP is a synchronize the time between the time server and the client. They're using the UDP port 123. Okay, this is port number they're going to be used. So assume that the link transmission delay is 1 second and take the device 1 second to process and the NTP bucket. So that's why that when the stratum number 1 sent to the next one, they should become the stratum number 2. So over here, this is how they're going to be calculated. What are the time difference between the R1 and R2? They might have a time difference of how many seconds. Okay, they might have a 2 second of the delay between router 1 and router 2. Okay, that can be calculated from 10:00. I send to you become 11:001. When I return back to you from 11:001 back to 11:002. So you can see that they have offset of 1 hours. 1 hour difference and also another 2 second difference. 1 hour and 2 seconds. 2 second delay, 1 hour is on the clock offset. Okay. Based on this information, I can just doing the calculation. So I'm going to be sync between the R1 and R2. This is how dynamically how they're going to be adjust through the NTP protocols between the server and between the client. Okay, that is on the NTP itself. So NSF and NSR are used together to ensure the service continuity. So true or false? So for these two is false. They they will not use together. You can only either select NSF or select NSR. So either select NSF or select NSR. They will not use as a together. Okay. So the answer for this as a false. Is okay? So any question from this on the high availabilities? Under high availabilities, any other question more? All right, this is where we're going through. So that protocol is important. You need to grab the ideas how to define the BFD, how to enable SNMP and NTP. So that's some of the command you might need to know how to perform it. Okay. So then next we'll look into this on the HCIE INS under the quality of services, the QoS topic. So QoS is also is the mark they involve over here is not a lot, but it's still about 9 marks for this purely the QoS question. So it means that in the 3 question of a QoS, 1 question is 3 marks. So let's say you can get this mark that is good, and this mark is not difficult to get. As long as you know the concept, you should be able to get the mark from the QoS question. Later, I'm going to ask you to perform, they have 3 lab on the QoS, just to familiar with this, how we perform on the QoS question, okay? I'll come up with a question and we do it together under the QoS question. So QoS is just to make sure our quality of the services. So try to not degrade our services to make sure that all the service can be sent out accordingly. Okay. But QoS is only be kicked in, you only activated when your link is get congested. When link is not get congested, everything will be just sent as normal. But why we need a QoS? You can see that last time, based on the traditional way of accessing to internet 20 or 30 years ago, what's the point for us to access internet? It be just pure for the data access, like go to the website or file transfer. That is what 20 years ago or 30 years ago that we are using the internet access. Compared to now, they're not only this, they also include together with the voice. We have voice, we have video, we have a lot of real-time protocol it be included. Okay, so that's why we need to make sure that the quality of our services is not being degraded. Let's say when link get congested. So as a network rapidly developed, service on the internet become increasingly diversified. Apart from the www, email or file transfer, and now it become to the IP phone, e-commerce, multimedia gaming, e-learning, and so on. They require a lot of bandwidth. Okay. In addition, enterprise users use the virtual private network technology to connect back to their branches from different locations. So all this you need to make sure that they can be sustainable, for our network can be sustained. Is all right? And for the diversified service, enrich the user life, but also increase the possibilities of the traffic congestions on the internet. In the case of traffic congestion, service can encounter long delay or even a packet loss. As a result, service deteriorated or even become unavailable. Therefore, a solution for resolve the traffic congestion on the IP network is urgently needed. Especially, QoS is the one who solve the problem. Yeah, is the one who solve the problem by handling how the traffic is being forwarded using the quality of services. Okay, how you need to be followed step by step. This is the way of the quality of service. So under the objective here, we need to master the QoS multi-field classification technology, token bucket algorithms, and also a QoS deployment solution on the live network. So where and how we deploy on these services. So far, okay? So for the QoS MQC configuration, okay, the MQC, we doing the modular QoS command line interface. Okay, what it means by MQC. So under MQC, it allows you to classify the bucket based on the packet characteristic and specifying the same services for bucket of the same type. This allows different type of the bucket to be provided differentiated services. Okay, and on the MQC entities, MQC involves 3 entities: traffic classifier, traffic behaviors, and also traffic policy. So always we need to have these 3 methods: classifiers, traffic behavior, and traffic policy combined to provide the MQC. So this is always. using this traffic classifier to classify the traffic, to match the traffic. The behavior is an action. What action you're going to be allowed, not allowed by the behaviors. And the last one, we combine. You combine the classifier and behaviors to become a policy. Okay, that is how we are doing, how we're performing on this. So far, okay, this is on the MQC configuration. We look into one by one. Let's check what is a classifier, what is the behaviors, and what will be the policy. So under the traffic classifiers, layer 2 traffic classifier rules: source MAC address, destination MAC address, VLAN ID, MPLS EXP, layer 2 protocol related field, and also ACL 4000 to 4999 rules related field. So that is the information inside the layer 2. That's where we can classify to, based on the source MAC address, destination MAC address, VLAN IDs, MPLS EXP, layer 2. That actually is belong to layer 2 or layer 2.5. Okay, that is what can classify using the traffic classifiers. And for layer 3, we can based on the IP DHCP, precedence, IP protocol type, real-time protocol numbers, port numbers, ACL 2000 to 3999 and 3000 to 3999. Okay, and ACL 6 2000 to 3999. So this is include the basic and also advanced. Okay, just basic. Okay, there's a difference from 2000 to 2999 and 3000 to 3999. That is on the classifiers you can be done under IPv6. So you need to know how to perform this. It's very, very important. It's very, very important. Let's say you do not know to doing this, you might lose 9 marks. Okay, 9 marks. 9 marks is quite a lot. Okay. Any questions? So the next one is on the traffic classifier configuration. All right. So the N parameters indicate the relationship between the rules in the traffic classifier is N, which means that let's say you have N O. Classifier can be have multiple classifier. If the traffic classifier contain ACL rules, packet match the traffic classifier only when the packet match one ACL rules and all the non-ACL rules. If the classifier does not match any ACL rules, packet match the traffic classifier only when they match all the rules inside the classifiers. Okay, they have to match everything within your classifiers. Let's say using the operator is N. When it's O, they indicate that the relationship between the rules is traffic classifier is O. The packet match the traffic classifier is the packet match one or more rules in the traffic classifier. It can be only match one, then it's okay. Okay, match one, that's all. You don't need to be match every single if match that you have. So by default in the Huawei traffic classifier, the default rules is using O. So second one. So means as long as I match one if match, that's good enough already. I do not need to match the second one. But this, it can be changed. You can change your operators to a logical and not logical or. Okay, that is what it can be adjust between the operator and operator or. And these are two things that can be interchanged. Is okay for the traffic classifier configuration. So classifier is more to classify the traffic. So where you come from, what are the DHCP you map when you come into me, and so on. That is where they come into your devices. And for the traffic behavior configuration, under the behavior configuration, this is more to action. What action that you applied? The action can be packet filtering, priority remarking, redirections, traffic policing, and traffic statistic collections. So that's where we can be added in. Like you redirect the interface, you're going to do the packet filtering, you're going to change the marking, you're going to perform the policing, and also you can perform the drop policy and so on. Traffic statistic collection. So you can say that, oh, how many things hit to this? How many packets have been hit to these behaviors? Okay, they can be doing the monitoring, record down the statistic of the traffic passing through on this interface or on these behaviors. Okay, you can run the traffic behavior name command to create the traffic behaviors, and this is what later part we need to perform together. So the next one is on the traffic policy configuration. Traffic policy is always combine your classifiers and behavior together. Okay, like you have a traffic classifier TC1. You have a traffic classifier TC2. You have a traffic behaviors B1. B2. So you have a TC1, TC2, B1, B2 as a behaviors. So after you have created all this information, then next you can do this. Traffic policy MQC as specified classifiers TC1 behavior B2 classifier TC1 behaviors B1. Sorry. TC2 and a B1. So this is what you can be mix and match. Okay, it's not exactly 1-to-1 or 2-to-2. So it's up to how you are specifying them. Okay, it depends how you're specifying them. Is that okay? So all right, this is how the traffic policy is being defined, and you have a classifier, behaviors, and also a policy. Any questions? Okay, so for the next one over here is called the MQC configuration examples. We have 1.1, 2.2, 3.3. So on this, on router A, they need to classify the traffic into the AF11, AF21, and EF. And RTB remark AF21 as a AF22 traffic. So when a detector coming in is a AF21, remark to AF22. So that is where we are going to go through how they perform this classification, behaviors, and also a policy. Okay, ready? So for ACL number 2001, root 0 permits source 11110, 02, 2222, 03, 3333. So I classify using ACL, 3 numbers. And classifiers for AF11 is 2001. 21 is 202. EF is 203. Okay. Behavior for AF11, mark the DSCP. Mark the DSCP. Mark the DSCP for the AF11, AF21, and EF. So I have a classifiers of 11, 11, 21, 21, EF, EF. So over here on the AF21, I do not call this as an AF21. Okay, I do not call this as an AF21. Because of DSCP, what are the value of DSCP that we have? DSCP value is from, what's the value? 0 up to 63. For the AF is only allocated to the AF 1, 1, AF 2, 1, AF 3, 1, AF 4, 1, and also 1, 2, 1, 3, 2, 2, 2, 3, 3, 2, 3, 3, 4, 2, 4, 3. So this is what they are classified into for the AF value. For the AF value for the DSCP. So do you know that what are the differences between the AF 11, 21, 31, 41? So what are those information? Do you differentiate? Can you differentiate between these four? AF 1, 2, 3, 4 and the AF 11, 21, 31, and 41. What is the difference between these? Do anyone have any ideas on this? Or you have no idea about this? What are the differences between? So you can recall back what you learned from your HCIP. They should have covered on this DSCP value. What is meant by the AF? Assure forwarding. Okay, it requires assure forwarding. Under assure forwarding, why we have a 111213, 212223, and so on. So what is mean all this information? So what's the difference between these two? Anyone? So as we still remember, inside the DSCP value, we have how many bits? 6 bits. Actually, inside that, in total 8 bits. But this one as a reserve. Okay, it's not being used. So they only consider the 6 bit. So that's why 2 power of 6, you get the 64. So that's why you have a 0 up to 63. Okay, that is what we can go up to from 0 to 63 of the combination. Combination is from 0 to 63, so it means a total 64. But it's not every single one has been used. Because when compared to the IP precedent is only using 3 bits. Okay, you have 000, 001, 010, 011, 100, 101, 110, and 111. So it's from 0 all the way to 7. It's 3 bit. But right now, we have 64 4 combination. How these two can be mapped into each other? How you map IP precedent to DSCP? How I map the DSCP back to the IP precedent? So that's why when you first starting on the DSCP, they will just concentrate on the first 3 bit, the high bit, the first 3 high bit. So 0, 0, 1. They have a 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. It's a map to 1-to-1, 1-to-1 mapping. Okay? At the beginning, this is how they are mapped into 1-to-1 mapping. But the next 3 bit, they will just utilize some of them. Like I mentioned just now, they have AF11, 21, 31, and 41. So what they utilize over here, they have this AF1. Under AF1, I have using a 5 byte. The 6 byte, this is not being used. So they're only using a 5 byte. AF1 is called 0, 0, 1. 1, 1 is called 0, 0, 1, 0, 1. When it's a 1, 2, is a 0, 0, 1, 1, 0. And 1, 3 is 0, 0, 1, 1, 1. So these two numbers, the 2 digit over here, is considered as the drop percentage. The drop percentage is be here. What's the percentage you're going to drop? 0, 1 is a low drop, 1, 0 is a medium drop, 1, 1 is a high drop percentage. Okay, the probabilities of the drop probabilities is from low, medium, and high. So that's just that they're going to be classified in this value for you to make it more detailed of the classification. You can classify data. They have a lot of data information. There can be FTP, there can be Telnet, there can be just a HTTP. So in this case, you can allocate different services of the data services, go to 1, 1, 1, 2, 1, 3. Make it more detailed. Okay, make it more detailed. Is it okay so far? So that's why from this, it will tell you that DSCP 10 or 11 DSCP 11 is not equivalent to the AF11. That's what I want to highlight to you. Okay, so how we get what is the DSCP 11 and AF11? Okay, AF11, this 11. 11 is from 0, 0, 1, 1, 0. DSCP 11 is using 1, 2, 4, 8, 8, 1, 1, 1, 1, 0, 1, 0, 0. So that is a DSCP 11. This is AF11. The 11 is 0, 0, 1, 0, 1, 1. Okay, 1, 2, 4, 8, 16, 32. So 8, 3, 1 is 11. Okay, But this one is not 11. This is 1. No, sorry. 0, 1. Okay. So they divide to 2 portions. There is a 1, 2. 1, 2, 4. All right. That is the numbers that you need to know how the differentiation from a DSCP value compared to the assure forwarding value. So DSCP 11 is not equivalent AF11. AF11 is 2 characters. Okay, one is meant for that is a priority number 1. Another one is considered as a drop probabilities. What are the drop probabilities for this AF value? Is that okay? Can understand on this? That's what I said that DSCP valued is not equivalent to the AFXX. Is it okay so far? Can you grab the understanding on this already before I continue on this? Okay. So let me come back to this. So that is how we assign. After we have an ACL defined, behavior defined. So I have a marking for 11, behavior is 11. 21, behavior 21. So that is on the one portion only under one portion. Under traffic policy, mark outbound. Under serial 0. So it means that when I'm going out from this interface, I need to classify these 3 address to AF11, AF21, and this is on the EF. This is what has been classified into. Okay, based on the configuration it done on the router A, is facing to the outbound. So far, any questions? Then next, on the router number B. MQC configuration on the router B. So this one you show that on the traffic classifiers, classified on the AF21, if mesh 21, if mesh 22, if mesh 21, and remark 22. Okay, there is a behaviors. Remark DSCP AF22. So I have this. When 21, behavior is 21. 21, sorry. 21, 21. and may coming inbound. When traffic come inbound, are you going to remark yourself? Remark the numbers from AF21 go to AF22. That is what they are highlighting from here. How they perform the remarking. Okay, remark from the QS value, from DSCP value of AF21 to 22. Is it okay? Then the next one is on the token bucket algorithm. Under the token bucket algorithm, so there's one you will needed to check what the sizes of the token bucket that you are using. So it depends on the size of your token bucket. This token bucket is more to implement for the traffic control. To say that, oh, you want to forward the traffic, make sure that you have enough token inside the bucket. Okay, this is a mechanism that measures the traffic passing through a device that's required the token. So the traffic, when they're going out, yeah, the traffic going across, they will always check, hey, I need to have this amount of token. Do you have sufficient token for me to go out? Let's say yes, it's sufficient. I will forward. Let's say not sufficient. I will just discard or cache the buckets. Okay, cache the bucket. Okay. When the packet arrived on the device check whether you have enough token. Let's say it's enough, I allow for transmission. Let's say if not allowed, then it meant for the discard. Okay, that is on the token bucket. So they have a keep on adding a bucket, the token into the token bucket. This is a traffic flow, and this is the traffic forwarding. They have sufficient token, you send out. Let's say they're not sufficient, they will not send. Yeah, that is on the token bucket itself. Okay. So next, for the single rate traffic policing parameters. Under single rate traffic policy parameters, the following parameters are involved in the single rate traffic policing. They have a CIR, CBS, EBS. CIR is the rate that you're going to put into the bucket. What's the rate you're going to be bumped in to the bucket? How many token, what are the token sizes you're going to be put inside the bucket? And the committed burst rate is considered the bucket size. How big is your bucket size? And they also have a extended burst size, the size of your another bucket. So they can have a two bucket. So they have two token bucket C and also a bucket E are used in this scenario. So they have a CIR. The float they're going to be put in to the token bucket. So I'm going to add on all. Right now I add 1 meg of token every second. Okay, every second I put 1 meg of token inside the bucket. Let's say the traffic, they have no traffic generating coming into this direction. My bucket will be overflow after few seconds or after 20 seconds. Bucket is full. When bucket is full, they will overflow to the extended bucket. Okay, extended bucket we call as a EBS. So we have CBS, okay, bucket C and bucket E. So only when they are overflow, they will fill over to the bucket E. Okay. So CBS is indicate the committed volume of the traffic that an interface allowed to pass through. Also the depth of the token bucket, how much I can be stored into the token bucket. The CBS information is considered using the byte. Okay, they calculate based on the byte of the information. The CBS must be greater than or equal the size of the device, the CIR. Okay, let's say your CIR is larger than your CBS. It means that every time you go in, you'll be always full, it's always overflowed. Okay. So they have a CBS, they also have a EBS. So under this single rate traffic policy, they have a single bucket as a single rate, dual bucket as a single rate, or color aware mode, single bucket as single rate and dual bucket as a single rate. So it means that one is based on color, one is based on, they'll just compare where do you have sufficient, not sufficient are going to be allowed. Or it can be color them first. You can give them a color before you're handling the information. Okay, so they're going to check a different status. So by using a single bucket, single rate, dual bucket, single rate, means that first they will come in, check your CBS. CBS not sufficient, go for EBS. Then EBS, I will send it out. For the color away, they're using the other way around. First, they will check, do this traffic has a mark or they have a color aware already to say that this is for the violations, or there is exit, or there is as a confirm. So they're going to have three different. One is exited, one is on the confirm, one is on the violations. Violation, let's say you give them a different colors or violation colors. They can, in this case, first they're going to check based on the color that you mark into. But for the color blind, no, they'll just follow one by one from confirm, exit, violate. For color away, they're the other way around. They first check from violate, check from exit, and check after to the confirm. So they're going to check a different process only on the single rate traffic policy. Okay, so they're going to using different way to check what the services I should be handling, how we handling the services. Okay, one is based on the color awareness, and the other one is called as a color blind. Default, they're using as a color blind. And next is on the QoS application. Under the application of a QoS, what we have over here, when we're doing the QoS application, the first thing we need to know is on the planning. A planning and also a deployment. Yeah, planning and deployment. In the principle, classification, remarking, and rate limiting are implemented on the inbound user interface, and traffic shaping is on the outbound user side interface. So you need to know what type of the services, QoS services, they're running on which location, inbound or outbound. Okay, queuing scheduling and the congestion avoidance are configured on the outbound network size. Queuing scheduling. What are queuing scheduling that we know? Do you know any queuing scheduling that we have? What are queuing scheduling that we have inside the QoS? So what do you know over here? So we have what? We have a priority queue, custom queue, weighted fair queue, okay, weighted round robins. So we have a lot of different type of queuing inside the queuing scheduling. And also we have a queuing or congestion avoidance. What type of congestion avoidance that we have that you know? So that we have a RAT, WRAT, okay? Random early detection and the weighted random early detection that need to be set from the outbound when going outbound. And configure rate limit for the priority queue based on the service requirement is recommended. And traffic classification, multi-field classification is recommended on the network edge, close to the user. When on the edge, we always do the complex classification. When come in, we're doing the simple classification. To simplify the subsequent traffic classification, behaviors aggregate classification is recommended on the equipment at the aggregation layers or upper layer to reduce the equipment load. So only you do the behaviors when it go into the middle, in the intermediate, then you set the behaviors. As the first place, you just classify them, who they are. And when you want to do some limiting, then you do it under the aggregated devices. In principle, bucket of lower priority service are dropped more and earlier than those have a higher priority service. packet of real-time service are processed using the queue drop policy. Signal protocol packet are not dropped. Okay. Because on the real-time protocols, you cannot randomly drop. You drop everything. Randomly drop, you'll be increasing the delay because real-time protocol, normally they're using UDP. UDP, they have no retransmission. That will be the drawback. That's why the signal you send into the TCP, you try not to drop the most. But when real-time, also we need to secure them to go to the PQ or a higher queue. Because let's say they have dropped the UDP port, packet will be dropped. In this case, the connection might be lost. Your voice will be stopped. Your video might be stopped because you dropped the wrong information. So under the planning, you need to know carefully what services you should be under, which categorize. Like your routing protocols, your voice traffic, your real-time traffic, or your office traffic. So how are we going to classify to them to the 7, 8 priorities from 0 to 7, or the DSCP value you can define from 0 to 63. Okay, that is where you can classify the services into. Planning is important, and the deployment location is important as well, where you should apply inbound, outbound, on the edge or under the aggregate devices. So you need to know where we should apply this deployment on the QoS application. And this is the next one on the service priority planning. So we have management controlled, voice stream, real-time videos, and the office services. Management control message include important packets such as the protocol packet used to communicate with the NMS and other devices, and are currently appointed for the running network. Such packet must be allocated to the highest. Normally, you get a 6 or 7. Okay, the highest. Highest is a 7. So you sometimes you get 6, sometimes you get 7. You see how important they are. But the voice stream normally we set as a 5. Low delay, low jitter, and the packet loss rate. Such packet it should be put into the EFQ. Okay, 5. Real-time videos, it can be EF as well. Require low delay, low jitter, and low packet loss rate. So you can put it as an EF. And office services have low requirement or jitter and delay. And generally, you place into the AF, assure forwarding, and also the best effort. So you can have a BE, it means it's a 0, or 1, 2, 3, 4 of the QoS value. This is where they are located based on the different services priority planning. This one, plan carefully. Some of them, they're not planned like this. They're planned based on the grade. A silver, bronze, and gold. Okay, they divide to have 3 different levels. That is what we can define into. So it depends on how you specify your priority on the QoS planning. Traffic policing and also a traffic shaping. Traffic policing must be implemented for the traffic sent from some NMS server, which are valuable to virus infection, to avoid attack on the voice and video services. Traffic sent from the NMS server has the highest priorities and is scheduled using the priority queue. Okay, so traffic policy, they can say that they can be filtered whichever information is not being sent. Okay, to avoid the attack for the voice and video, everything must be using the priority queue, PQ. And to prevent some office services from launch DDoS attack to affect other services due to virus infection or bandwidth overuse, configure traffic policy for the access flow based on the SLA. Set the priority access traffic to the lowest level so that the access traffic is forwarded in the best effort mode instead of the being direct discard. This configuration helps to leverage network resources and improve the customer satisfaction. So this means that, let's say you can control, because based on the car can specify based on the services. When I detected you use more than this amount, I'm going to change your priority to the best effort. When best effort means that you can be using only when the rest is forwarded out already. you are the last one who able to forward the information out to set using the traffic policy and traffic shipping. Okay, that is the two things that you can be providing by control into the live environment. Okay, to protect on the attack by the DDoS. And the last one over here is on the queuing scheduling and the packet drop policy. So enable the behavior aggregation classification for the incoming packet of edge routers on the backbone network so that the queuing scheduling is performed based on the priority carried by the packet on non-edge router on the backbone network. Mapping between IP precedent or DSCP and the MPLS EXP value are generally configured on the edge routers on the MPLS network connected. Okay, so means that when I come in, I classify all of you first. I do not do the scheduling. Scheduling, you do it in the middles. Because in the middle, you get congested. Because all the edge connected to aggregate, that is where the point you can easily get congestion. That's why they're going to be set up the behaviors to define the queuing scheduling inside the aggregate devices. Okay, so for management control message packet for voice call, video conferencing, video call have a high priority to define as a PQ. The rest for other services using the weighted fair queue. So they are weighted, but everything is fair on the queuing. And the queue drop is used for the priority queue, such as voice video call, in an effort to forward the PQ packet without dropping them. Packets are lost only when the PQ resources are exhausted. To prevent global TCP synchronization, weighted random early detection is used inside the weighted fair queue services. The weighted fair queue is to perform queuing scheduling. So based on what are the queue that you have to send out. So under queuing scheduling, the queue they be queued behind, before they can go out, they need to queuing. So the queuing they have provided, they also have a limited. They can be queuing up to the maximum queue drop. So to prevent the queue drop inside the queue, they define this weighted random early detection. Drop before is up to full queue. Set the high packet drop threshold for the high priority traffic and set the low packet drop threshold for the low priority traffic so that the low priority traffic face a higher probabilities of being dropped. So that is what that can be done on the packet drop policy. Okay, packet drop policy. So this one, later I will show you how this can be configured because this one is very important. In your exam, you need to know how this is being done on the configuration. Okay, it's very important. Later come back, I show you the lab. All right, that's on the QoS topic. All right, let me just share you the lab. Hold on. Maybe later when you come back for the break, I send you the link. All right, let's take a short break. Okay, 3:05, 20. So you come back to 3:20, okay, and continue with the QoS lab. All right, let's take a short break now. All right, is everybody back? So I already shared the lab into the group. So let's open up. So that will be the topology. So I will have a AR and also R. So it depends on which one you can be accessing using which one, which router you can use. You can using routers or using the AR routers. So you can just start 3 of them, get either one, or you can start both as well. Okay, let's start that first. Then I'm going to show you how and what we're going to do from here. Okay, started. All right, let's say it started, then we're going to do this lab. So first from here, I already show from here to say that classify into 3 classes. On R1, AF1121 and EF, based on 1.1.1, 2.2.2, 3.3.3. When go up to router 2 said that allocate 5% bandwidth for the AF11, remark AF21 to AF22 and allocate 5% bandwidth, and allocate 30% bandwidth for the EF. So that is what we need to perform. Okay, we do it step by step from traffic classifier and also a traffic behaviors. So you can do it on R1 or AR1. It's up to which one that you are using. Okay. So before that, let me just copy this command into it. Okay, so for R1, display IP interface brief, you should see that 1.1, 2.2, 3.3 has been configured as a loopback 1, 2, 3. All right, and from here, you should able to go to router number 3, display IP interface brief. You have this address of 23.113, switch 2, display IP interface brief. You have this destination 33, 33. So the addresses are slightly different. Maybe I think all of you just try to using the R1, R2, R3 at the below here first. Using R1, R2, R3 first, yeah, R1, R2, R3, we're going to perform this lab. Classify 1.1, 2.2, 3.3 first. So in this case, for the first classification, what I need to perform here is okay. So first, I need to set at ACL 2000. So every single ACL is classified one destination. Rules permit source 1111 0. ACL 2001 rules permit source 2222. ACL 2002 rules permit source 3333. Good. This is on my first level of the classification. Okay, classification of first layers. After this layer classification, next I'm going to specify this as a traffic classifiers. Okay, traffic classifiers into this as a AF11, or you can see that that is a TC1. Okay. Hold on, that cannot be defined. All right. So I think that's my mistake. This one cannot perform a traffic classifiers. Let me just double check on AR1 first. Display IP interface brief. Let's try on this. Sorry, I want you to define AR1, AR2, not R1, R2, R3. R1, R2, R3 seems it's not supporting on the traffic policy. So go back to the AR1, AR2, and the switch 2 on top. Okay. So this one I can remove. Okay. Okay, just focus on these three first. First, I will do it back the same step to classify the 1.1, 2.2 to 3.3. Okay, they have no ACL configured. I define ACL. Permit source. Okay, ACL 2000, 2001, 2002, and followed by traffic classifier. Traffic classifiers, I define this as a TC number 1, if match ACL 2000, TC2 2001, CC3 2002. So this is what my classification needs to be done. And then I will do the remark. Traffic behaviors. Traffic behaviors as a TB1. So there need to be assigned what? Remark DSCP AF11. TB2 21. TB3 EF. Okay, so I'm going to change the remark AF11, AF21, and AF and the EF. So this is doing the marking of the traffic. Since that when they're coming in, there's nothing. They're not doing any information yet. So after that, the last step I need to perform as a traffic policy. Okay, MQC, modular QoS class. Okay, MQC and classifiers for TC1 map the behaviors TCB, TB1. Okay, TB2, TB2 map the TC2. TB3 map the TC3. Okay, display this. So this is what I'm mapping. I map between the classifier and behaviors, TC1, TB1, TC2, TB2, TC3, TB3. Yeah, this is what I have been defined, the behaviors and classifiers. And then interface gate 001. Traffic policy MQC outbound. So when I'm going out from this interface, I apply the MQC policy. Instead of policy, I have 3 classifier and 3 behaviors. And what will be the result in this case? So for us to check the result, I can just double check from here. Start data captures. Let me show you the result, what we're getting based on this information that we did. Okay. So from this AR1, let me ping a device to 3.33.33.33. Let me check display IP routing tables. I know how to go to 33.33.33.33. I ping 33.33.33.33. Okay, it's pingable, all good. From 12.1.1.1, you can see that under IPv4, the DSCP value is 0, CS0 as a best effort. Okay, is a best effort because this one is not using a source of 1.1 or 2.2 or 3.3. Let's say right now I'm using a ping minus A 1.1.1.1 go to 33.33.33.33. It's pingable. Okay. 1.1 go to 33.33.33. You can see that under my IPv4 headers, there's one called AF11 here. DSCP value 28. Yeah, 28. AF11. So far okay or not? Minus A 2.2.2 33. So I will have a AF21. Okay, AF21. And the last one, ping minus A 3.3.3 33. I will get EF. So this one, it means that my classification and the behaviors are applied to the traffic that I configured here. Okay, everything is applied correctly. Is okay? So far, any questions? Okay, no question, huh? So this is the first step. Second step is that, let me just bring out this. This is on the AR2. Allocate 5% bandwidth for the AF11, remark AF21 to 22, and allocate 30% for the EF traffic. So how I'm going to do on this? So I need to do it on router 2. Remember, this one is always a hop by hop behaviors. It's using a per hop behaviors. Every single device, they will using their own method to send this information out. Okay. So from the AR2, first, I can just direct to the traffic classifiers AF11. If match DSCP AF11. Traffic classifiers AF21. If match DSCP AF21. Traffic classifiers EF. If match DSCP EF. So because of R1, they already classified the address. So in this case, on R2, I do not need to go through one more round to get what you have. Okay, so I can be just immediate for AF11, AF21, and EF. When I match the value, the DSCP value, I can classify already. Okay, I do not need to know where is your source address anymore. Well, this one is considered the aggregate. Under the H, it classify based on ACL, it classify and remark them. When it come to my point, I just based on what you remark already, I'm doing my per hop behaviors in the meters. So that will be much simple compare you going to go to do everything again to classify based on the source address, okay, or destination IP address and so on. So it'd be very complicated in this case. That's why just now on the planning and design, they ask that do it on the edge. Configure on the edge before you go for the aggregate. Aggregate, you should be doing the simplified filtering. Okay? So after this, next is on the traffic behaviors. This traffic behaviors, as for the AF11, I said that BAF11. Behavior for AF11, queued AF percentage bandwidth for the PCT percentage 5%. Okay, you do it like this. So I allocate 5% into this interface. That is a command. Okay, this behavior, I have a queuing AF bandwidth for 5%. This is allocated. This is on the behavior for the AF11. All right, I quit and traffic behaviors BAF21. This is behavior for the AF21. First, queued AF bandwidth percentage of 5%, and also remark DSCP to AF22. So they have two behavior in this case. And behavior EF, traffic behaviors, EF. Qt, EF, bandwidth, percentage for 30%. Okay, that's what I define. And after that, traffic policy, PHP, per hop behaviors, classifiers, AF11, behaviors, BAF11. Okay. And on the routers interface gate 001, traffic policy inbound. Traffic policy PHP inbound. It's not support into the inbound CBQ. By right, it should be supporting. Yes, questions? Okay, in this case, let's say they do not support inbound, I do it on outbound. Interface gate 002, when I send out, I will set that traffic policy, bhop behaviors, outbound. Okay. When I send to switch 2, okay, I send to switch 2. So right now I've done all this already. What I need to do, I need to just open another Wireshark from here, start data captures, going to the switch 2. So it's just to check what are the results that I'm getting from here. Now this is a switch, okay, but it's okay, never mind. Right now I go from router number 1, ping minus A, 1.1.1, 33, 33. Okay. IPv4. This one are still using the AF11, no difference, AF11. Because I'm not doing any remarking, I just allocated 5% bandwidth for him. And next, using the 2.2. 2.2, then you can see the difference over here. From 2.2, it's changed to AF22. In this case, it means that my policy is working fine right now. From 2.1, right now, when I go out to the switches, it becomes 2.2. Is it okay? Do you see the difference right now? From 1.1, from 2.1, when I pass through router 2, when it went out, you will get the AF22. But for 3.3, there was no changes. Okay, 3.3 no changes because I just allocated the bandwidth. Okay, allocated bandwidth. It's still EF. Okay, there's no difference from here. So in this case, let's say I want to do some checking on this, you can display traffic policy, apply record to this. It's what I applied on the outbound. Inbound, it should not be supported. Apply failed. Okay, so this is where I apply on the outbound. So I display user defined. Okay, user defined means that the policy that I built is called PHP. If match AF11, the behavior is a BAF11, and the bandwidth is a 5% bandwidth. And the drop method is using a tail drop. I do not have any drop policy over there. Okay, no drop policy, 5%. Okay, they have a to 1. When at 5%, when they mark, I will change to the AF22. Okay, this is on the EF. Is that okay? %30. So all right. Based on this traffic classifier, traffic behaviors, and also traffic policy. Is there any question that you want to ask? Okay. And also over here, let me just give you some ideas about on the map table, QoS map tables into the devices. So every single interface that we have, let me just show you from here. Hold on. Interface gate 001. Let's say I have this, display this, undo traffic policy, PHP. Yeah, right now it's empty already. So from here, actually, I can check that display QoS map tables. They have a map tables, okay? Display QoS map tables. So the map table over here, they have this type of map tables. .1p to .1p, .1p to DSCP, .1p to .1p to build, .1p to the IP president, DSCP to .1p and DSCP to DSCP, DSCP to IP president. So let's say the question said that right now you want to map the tables from the .1p go to a DSCP. Okay, as a .1p go to DSCP. Let's say I want to do it. Okay, that is a value that we provided, like 1 to 8, 2 to 16, 3 to 24, 4 to 32, 5 to 40, and 6 to 68, 7 to 856. Let's say right now they ask you to do some changes from here. Change the tables. Let's say the tables will be something like this. I'm going to change down 0 to 0, 2 to 16, 3 to 24, 4 to 32, and 5 to 46. Let's say I want to do all this mapping. How can I map this information? I want to map this information. Instead of I'm going to use the standard one, I will say that I want to use a mapping like this. So I go to the QoS map tables .1p to DSCP. Go inside already. I said that input 5, output 46. Input 4, output 32. Input treat, output 24. Input 2, output 16. So it means that when I come in this value, what should I map to? When I come in this value, what I should map to? But this one is not apply. This one is just set the mapping tables. When I check again, display QoS, map tables dot 1q dot 1p to DSCP. So you can see the value has been modified. 5 is 46, 32, 24, 16, 8, according what I defined. Whichever is not defined, it will just remain. And now, how to apply? To apply, you go to the interface gate 001 and say that I want to trust 8021P and overwrite. I trust whichever is coming in and overwrite your number from .1P, go to DSCP. Yeah, that is what I said, that when it come in as a layer 2, I trust, then I overwrite with the value that I define here. Okay, that is a command to say that I accept whichever will come into me and I'm going to be override with another numbers. Is that okay? That is one of the things they might ask you in the exam. To change your map tables. So you need to know how to change your map tables. This is a command. QoS map tables from .1p to DSCP. Then you just change according what they're requesting. Is that all right? Any questions? Okay, no question. Then the next one I want to show to you is on the drop profile, the WRED and also the RED, random early detection and rated random early detection. This one will be inside the queuing, inside the queue. So I need to do it on router number 2. So I do it on the same routers here. But from here, I'm going to specify like this. First, I need to build the drop profile. Okay, drop profile is called D1. It's a WRED, DSCP. I changed the weight. We default is using IP precedent. I changed to become DSCP. And I say that DSCP followed by, this is on the, let's say I want to drop on the AF1. AF11, low limit. Low limit, so it's from 0 to 100. So what's the low limit? The minimum limit, let's say it's from 60. High limit, go up to 60 to 100. It go to 80. And discard percentage. Okay. Discard percentage from 0% up to 1% to 100%. So I make it as a 60%. There's a drop profile. It means that, let's say in the queue, inside the AF queue, let's say your queue percentage start from 60% onward up to 80%. Within this 20%, I randomly drop the traffic of the AF11. I start to drop AF11 traffic within this period of time. From 60 to 80%, I would drop 60% of the AF11. Okay. Any more than 80, you're doing the queue drop. This is called the drop profile. Let me display this. This is my drop profile. Is that okay? This is the drop profile. And after you have this drop profile already, you're going to define this inside the traffic behaviors. So I need to have this already. I go back to my traffic behaviors. That is called behaviors AF11. I will just add the check from here. They have a QAF bandwidth percentage 5. I will say that I have a drop profile D1. Put inside. Okay, so right now I have 2 information here. Okay, 2 information. So when I check again, displayed QoS, traffic policy user defined. So from this right now, I have a first one, AF11. Behavior is a BAF11. They have a 5% bandwidth and they have a drop method using weighted random early detection and using a D1 policy. Okay, using a D1 policy. Is it okay? So your drop profile, it can be do it inside here, or you can do it inside the Q profile. Okay, this is one of the way to assign this. Another one, you can go to the QoS queuing profile. Let's say I will just say that this is a Q1. Instead of Q1, from here you can check there's nothing at the moment. You can also check and define like Q 0 weight of how many? Weight of the percentage of the weight. So I can be set that it's a weight of 1. So there is a second queue. Second queue from 0 to 7. Queue number 2, I have a weight of 9. Queue of 3, I have a weight of 21. And queue of number 4, weight of 64, 63. Let's say like this. Okay, display this. So this is what I define. Let's say you're going to have Q0, Q2, Q3, Q4. I create multiple Q. Okay, and then I'll say that, and the Q, maybe I add a Q1 as well. Weight number 5. Okay, display this. So I Q1. And also I can put the Q1 with the drop profile D1. I need to set as a scheduling first. Hold on. The scheduling, this is how it defined. Before that. So after I do the queue for weight, I need to set schedule, weighted fair queue from 0 to 4 and priority queue to 5. Yeah, assign. From 0 to 4 is all weighted fair queue. So queuing number 1, I can set the drop profile D1. This is what I can define here. And then after you have this, you can apply into the interface. Interface gate 001 and set that QoS queuing profile Q1. Okay, apply using this way. So you can do it inside the traffic policy, traffic behaviors, or you can using this inside the queuing profile, So over here, how many things we learn over here? Maybe let me just open up this. Okay, I can write something from here. So just now, the first thing, we have a traffic classifiers. This one is just to match. Yeah, just to match the traffic behaviors. In the traffic behaviors, we always doing the remark. Am I right? We also can doing the drop profile. Okay. We also can set the bandwidth. On the queue, and we have a traffic policy. Okay, that is combination of the classifiers and behaviors. Am I right? That's what we learned just now. So for a drop, we have also learned about the QoS map tables. Yeah, map tables. Table mapping, like from 802.1p, how they map to the DSCP. Okay, yeah, once you want to change, you also need to do a trust.1p and override it. After I trust your information coming in, I override your information. We also learn about the drop profile. Under drop profile, you need to set as a DSCP and what is the low, high limit, and the drop percentage. What are the drop percentage is going to be set under the drop profile? The drop profile can be go to your behaviors as well as they can go to the queuing profile. Yeah, you can set the queuing profile with the weight of every single queue. Okay, the weight of the queue, and you can set the different scheduling. Okay, you can set the scheduling of the queue. Okay, and also you can put the drop profile. All right, that is what I go through just now in the QoS traffic classifier, behaviors policy, QoS map table, drop profile, and the queuing profile. So that all this you need to grab it, know what it means. Okay, make sure you have fully understanding on this. Okay, although it's not a lot of mark, maybe it's just around 9 mark or less than 9 marks, but when you look in this question, it's a simple mark. It's an easy mark you should achieve. Okay, you should able to get. Is it okay so far? For the QoS part, you have any questions? The weight value is not to say that either is prefer or less prefer. The weight value actually is said that what are the weight that the higher the weight means I can send more. So actually it's a weight under weighted fair queue. They said that when you have higher value, it means that I can handling more information under that queue. Yeah, the weight of that means that it will be more important. I can send more information from that queue. But actually the weight after that will be calculated by your weighted fair queue. Whereas weighted fair queue, they're going to have take a lot of consideration to do their own calculation. But you can tell that when they have a higher value, means that they're handling more of that queue. They give it more percentage of the queue. You can also consider they have a higher priorities, but depend on the scheduling that you are using, based on what method they are calculated on your weight. Okay, so they have a different meanings over here. But from here you can say that whichever they have a higher numbers means that you can be handling more information. Okay, that's why the weight, they have no zero weight.
Not specific.
They are no, they have not specific. By default, it's all one.
One value.
Yeah,
Okay.
one for all by default.
Okay, thank you.
Okay. But let's say in the question they ask you to change, then you need to change accordingly. That's how I changed just now inside the. This is how I change Q profile. Yeah, this way we can change the information. Is all right? So let's say it's okay. Over here, I will just going to highlight one more question. Last question here. It's also related on the QoS, but this is not fully considered a QoS. Okay. Hold on. All right. So let me just clean up this. All right. So right now I said that based on one of the interface, like R2 gig 001. Okay. Only on weekday. Okay. Monday to Fridays. 8 to 8 o'clock to 6 o'clock. Control filtered using the TCP port from 6801 up to 6999. Okay, UB control. Control based on the speed, they can only running on 1 Mac. Let's say within this time, within this period of time, Monday to Fridays, when I detected this port number, I will have a limit of 1 Mac of traffic on this interface. Outbound. Outbound. When going out from this interface, when I match your TCP port within the range, I will limit you only can using 1 Mac of traffic only. So what we can do in this case? So first we need to classify what using the ACL. Based on this ACL, I'm going to handling using the police sync, the committed access rate with the 1 Mac speed. Okay. First, we need to know how we can classify based on the requirement dimension. Weekdays, Monday to Friday, 8 to 6 o'clock. Based on the port number of 6881 up to 6999, they can only have 1 Mac. Okay, what we can do over here. From here, I'll show you on the command line here, based on requirement on top. Okay, on this SIM port, okay, under the SIM port. First, I have to specify the time range. The time range from Monday to Friday, 8 to 6 o'clock. So what I can do from here is, first, there one command is called time range. Okay, time range. So I define a name that's a work. Okay, specify the start time. Start time is 08:00 to 18:00, followed by define the day, daily, off day, or working days. So just nice that they have one called working days. Okay, working days. So this is my time range. I said a time range is called work from 8 to 6 for Monday to Fridays. Then I define AC out 3000. Rules permit a TCP destination port. Okay, port equal greater, less, or range. Range from 6811, 6881 up to 6999, and followed by a time range work. Okay. That is a command. I classified already. When detected within the range as my destination port using this port number as a destination, I will classify to the ACL 3000. After I have this 3000 classified already, I go back to my interface gate 001 and say that QoS car outbound ACL 3000 and CIR. Committed information rate, I give you 1024, 1 MAC. Okay, 1 MAC traffic only. So this is how we're going to limit using the ACL as well as using the time range. This is more to security control and also to handling the bandwidth control by using the CAR and the ACL. So always this should have 1 or 2 questions coming from your exam. So you need to know how this can be done by using a time range, by using the ACL, advanced ACL, and how to perform the CAR from the interface. Is that okay? Is this okay based on this question on this? Okay, now any other questions for the QoS? So this is what I has been going through with all of you regarding on the QoS question. This one is important. This one is important. So whichever I highlighted to you is all important. So you need to know what has been done already. Okay, make sure you have take note on all this I mentioned. It's very, very important. All right, so let's say no any other questions. So for my training part, I already completed already. Okay, from my side is already completed. And now I want you to show it to you. We need to take the post test. I need to give you a test. Okay, I need to give you a test. So right now I will share the link into the group for you to access to the exam system. Okay, let me just copy the link. Hold on. So do you see that, the link? So you can click on the link and log in. Let's say you have no account, you can just register an account. Okay, let's say I have no account, it just registered. It not take so long for registration. Okay. This is how you should log in. So let's say you have username password, you just log in. Let's say if not, you just create a new account. Just create a new account. Okay. After logging in, you select this. You can attempt the quiz now. But before you attempt the quiz, they will ask for the enrollment key. They ask for enrollment key. You put the password that I share into the group as well. It's called 022020 underline Nick. So that is your enrollment key for you to accessing to this test, the post test. So in total, this post test have 10 questions. Have 10 questions only. So I want you to do it right now. Okay, do it right now for the post-test exam. So I will give you about 15 minutes to finish the 10 question. Okay? You can start now. Let's say if any question, you just let me know. Just voice out and let me know. Yes, correct. That's the one. There's a password. There's a where is the enrollment key.
Nick, password for my email. That's correct.
Sorry.
On info site LMS.
For your password, incorrect.
Okay.
No, there's enrollment key and the password are different. This one is an enrollment key. The one I just post into the WhatsApp group is enrollment key.
Enrollment key and account info set LMS different password or the same password?
To log into the LMS, you have your own account. You create your own account. I did not. The password is you set yourself. I did not have the password.
Yeah.
Okay. So that actually, maybe I just rephrase it. This is not called a password. It's called as a enrollment key.
I forget. Wait.
You forget. You can reset the password. Let's say you forget.
Reset for account info set.
Yeah, reset your password. So it means that you can set the forget password. Let's say you log out.
Okay,
So
okay.
when you log in, you can set that forget your username password over here. Okay. You can look in my screen. You can forget your password. You put your username and search. They will send you the reset password. Okay.
Okay. I try. Thank you, Nick.
Thank you. All right, is it already completed or still ongoing? Okay. click on the submit all and finish, they have no response. Let me just try it out. Hold on. Can't click. Just give me a moment. How about on top, they have one called finish attempt. You try again to select the submit all and finish, because they will prompt a confirmation for you to click. They should show a confirmation. So is it everybody not able to submit? Because for myself, I'm able to submit the result. All right, all right. All right, good. That know that all of you that have already submitted. And after you submitted, the next thing I would like you to perform here is on the appraiser. So there's another training appraiser form I want you to fill up. So I will share another link to all of you. This is on the appraiser. It's a Google form for you to fill it up. Can you please fill it up for me? Thank you. So they have another way for you to practice your questions over here. So whoever already done on the appraiser and also the exam, you can go back to the home page. Okay, go back to the home page of the LMS and select Huawei RNS. From here, you found that one called HCIE RNS. By you to accessing to this, you need to ask for the enrollment key. Class number, you can just leave it blank. Okay. Class number, you can just leave it blank. It's all right. You can just put HCIE RNS. That's good enough already. So from here, when you want to access into here, they should ask you, they have a request for enrollment key to request access to these pages. So from here, you need to put the command. Okay, just put a command. It said that HCIE RNS Zoom Nick. You put the command with this command to accessing to this. So there are some questions for you to practice, okay, before you go for your written exam. Okay, this is where you can practice yourself and before you go ahead for your exam. So you can come here to request access. I think by tomorrow or next week, they will allow you to accessing to these pages. Okay. For the one attempt, only for the post test. For the post test, it's only one attempt. But when you enroll for this HCIE RNS, you just put the command into it and enroll me. So I think by latest Mondays, I will give you they will give you the access. Then you can have full access into all the tests inside. They can be doing multiple times. They have no limit in this case. Only the post test, they have one attempt. The rest, they have no. Okay, the rest they have no attempt. They have no limit for attempt. Okay, that's correct. It's all right. So make sure all of you finish the appraiser. Okay, finish the appraiser. And one more last requirement over here is I would like to take a group photo with all of you. Yeah, take a group photo with all of you. So do you mind for us to just open up your cameras? We take a group photo. So as many as possible. So we have around 30 of us. All right. So finally, I saw you after 10 days. Okay. Hope that you can learn something that we're going through about 10 days. Let's say you still have any question into the futures, you still can just ask direct from the group. Okay. Ask direct from the group. Okay, we wait for one more minute. Wait for the rest to open up their webcam before I capture the screen. Okay, 1 more minute. All of you are very quiet. Okay. Okay, another 20 minutes before I captures. All right. Hold on. Someone sending message. Okay. So after you're done the appraiser, make sure that you come in and take the photo together. Let's say without any webcam, it doesn't matter. It's all right. All right. I will count 3, 2, 1. Then you just smile. All right. Hold on. Someone message. Okay. No worry. I say cannot. It doesn't matter. All right. 3, 2, 1. Smile. Okay. That's good. Thank you very much. Thank you, everyone. So let's say in the future you have any question, you can just WhatsApp me. So I think that everybody have my WhatsApp numbers already. I in the group. So you have my numbers. Let's say anything, you can just direct message to me, or you can just ask direct from the group. So I wish that all of you can pass your exam as soon as possible. Okay. So before, I don't think they will very soon. They're going to change the question. They will not change the question right now. As long as what I mentioned to you, you just get ready, get prepared well before you go for the exam. It's okay. And try to do more on the written exam that inside the LMS. Try to practice more before you go for the exam. Okay. And let's say you found that the question inside the LMS is not correct, you just let me know. Let's say you found that this is not the correct answer. You just send a message to me. I'm going to double check for you. It's okay?
Okay.
Okay. Thank you very much. So thank you.
Thank you.
Thank you, Nick.
Bye.
Thank you.
Yeah, thank you.
Bye.
Bye.
Thank
Yeah,
you.
thank you.
Bye.
Thank you. Bye.
Bye.
Ya udah jadwal.